Hello fantastic people, I hope you are doing great. Today in this a little bit longer tutorial we'll implement crazy inventory system, so it has quite a lot of different features. Of course we can pick up items, some of them are stackable, some are not, so for example the flowers and the health potions are not. We can of course throw anything we have in the inventory. When the items are stackable, they stack together as expected. So this is pretty neat. Then of course the inventory space is limited, so we are not able to pick up more stuff than we can, so more than we should have. Then that's just a part of it, because we also have quite a lot of automations. So for example, we have game item prefab, which automatically sets a lot of its own properties based on the definition of the item that we have. So we'll do that too. Also, you see we adjust the names of those items and do quite a lot of different stuff, like automating the creation of inventory UI. So for example, let's say I don't have it and let's say my inventory space on the character is of size 4, then I can simply just generate new UI without any problem. So you see there's quite a lot to cover, so I hope you'll enjoy this tutorial and yes, have fun. Okay, so because the implementation will be a little bit extensive, I would like to walk you through what we'll be implementing. You see over here we have this scriptable object, cursive text, and also we have several mono behaviors. I try to mark them with color so they stand out, because this is not very common when you are starting out, but sometimes you may want to actually create classes which are not mono behaviors or scriptable objects, so they serve as like intermediary objects that just hold some data and do some stuff, but they cannot be instantiated in the game directly as a game object. So the first object we'll be creating is the item definition. So this will be, as the label over here says, scriptable object. This will contain all the information about the different items, or rather fields for those items, like name, is it stackable, and this type of stuff. In our implementation we'll keep it rather simple, but obviously you could keep their type of the item, for example weapon, armor, and so on, so on. So then we'll, as we see here, create several instances of that. This will be already inside the inspector, or rather the project window. So you will not have to create separate classes for each type of item. So this is pretty neat. Then we'll implement something called item stack. And this is like intermediary object or class that will serve basically to pass information around. It will basically have some functionality, but the main idea will be to have item definition. So just to mention, okay, in this stack I'm having, for example, planks, and I'm having 5 of them. So this is the idea behind the item stack. Then we'll have game item, and this is the actual game item. So this will be literally the thing having sprite renderer in game. This will have if we need a rigid body, collider, and so on, so on. So this is like already game object that will store all the information about the particular item that's there on the level somewhere, for example lying on the ground. Then of course we'll need a inventory. So we'll implement inventory as a mono behavior, because obviously we want to drag and drop it as a script on different objects. So for example, our character may have inventory, but also the enemies may have, our NPCs, and so on, so on. So this is pretty important. So this will be part of our character. And now this inventory will have list of inventory slots. And of course, in those slots, we will be able to hold different item stacks. So this is the basic idea behind that. Then, because obviously we want to be able to pick up the items from the ground, we'll have a class called item collision handler. So basically this is what will handle that particular thing. So it will be responsible only for picking up items, or basically different behavior we want to do when we collide with item. Then we'll also have something called inventory input handler, which will be literally just because obviously we'll have a UI, right? And we want to change which slot is active. So basically we'll use the inventory input handler to mark which slot is active. Now there is, I see there is one more small class missing, so let me quickly add that. So it will be also mono behavior, and it will be called item, or rather game item spawner. It's not here because I extracted it from the inventory. So basically, sometimes when we throw or leave item on the ground, we'll want to create an item in game. That's pretty obvious, right? So in order to do that, our inventory will call a method on game item spawner to create that particular item. Now, because sometimes there might be different things that may go wrong. So for example, other script may try to remove an item that is not there, or for example, we may want to try to add something to inventory when the inventory is full. We'll implement our own exceptions for that. I think this is pretty neat thing to know, and it's pretty useful, so I would like to show you how to do that. Then on top of those ones, we'll build UI inventory slot and UI inventory, which will be nothing more than basically handling the displaying and changing the state of the inventory. So the pretty important thing here is we'll use, as you see, we'll use some events. So our slots will inform the UI slots using events that the state changed. So I think this is pretty interesting and will be pretty fun and a great opportunity to learn a lot of stuff. So let's go. Just wanted to let you know that everything we'll create in this tutorial will be available on my Patreon together with other items. And of course, I will be creating more content and more stuff will be available there. So you can consider becoming a patron for those goodies that are there, but also because you may want to support me, which I would really appreciate. In case you would be interested, you can go to the patreon.com/ptit and the rest will be pretty clear. Okay, so I'm starting out just having this little elf walking around and literally nothing more. So the first thing we'll want to do is to create the item definition. So I open scripts folder, create another one, and call it inventory system. Inside of it, I create my first script and I'll call it item definition. Let me open it, zoom a little bit in. I move it to inventory system namespace. So now I'm removing that. Basically what it means, the class will not be available out of the box. In order to use it, you will first have to import or use the using statement with the inventory system. So using inventory system will make the item definition available for you. Otherwise, it won't be available. Okay, so first thing we said is that it will not be mono behavior, but rather scriptable object. Now, because it's scriptable object, we want to be able to create it in the project window. So I will show you in a second. In order for that to work, I need to add a attribute. And my attribute is called, or maybe not my, but the attribute itself is called create asset menu. And it has some parameters. For us, the important ones are menu name. So here I will call it inventory/item definition. So basically this will create this path in the menu. You'll see that in a second. And then file name is basically when the file is created, how it will be called, and let's call it new item definition. Awesome. So we have that. Now our item needs some fields. So first let's create serialized field called private string name. Awesome. Then another one for storing the information if it is stackable or not. Yes. So basically sometimes we want to have just one item because it's very big or it's very difficult to, you know, combine it into different ones. So for example, the stackable items would be nails, right? So if you have a lot of them, there's no problem. You keep them in one place in one small bag. On the other hand, you may have some items like, for example, sort, which is you know, you cannot combine several ones to keep them in one inventory slot. So basically, this is what will dictate if that is possible or not. Then we'll want two serialized fields for sprites. So first one will be sprite that we want to see in game. in-game sprite. So basically when we drag and drop the item on the ground, that's how it should look like. Then another one to have UI sprite. So when it's in the slot, we want to have that icon over there. What's important? Maybe let's do that. What's important in our tutorial, we'll use the same sprite for both, but I just wanted to show you how to do that. So because it's pretty common use case, so I thought it's good to implement that too. Now, because those are private, they wouldn't be accessible outside those item definitions. So we want to create properties on top of them. So public string name that returns name, public bool is stackable, public sprite in-game sprite, and then public sprite UI sprite. Awesome. So we have that. Okay, and I think for the definition itself, that's all. Now, because we added the create asset menu attribute, we can do something very crazy. So first I create folder for my scriptable object, so scriptables, and inside of it, just to keep everything tidy, I put another folder called item definitions. Awesome. Now create, you see over here I have a new menu that allows me to create the item definition. And first one, let's create maybe health potion. Boom. Its name will be health potion. I don't want to make it stackable, so it will be just so it will be occupying the whole inventory slot. In-game sprite over here, and UI sprite as well the same. Now I'll repeat it 3 times for other items I have. So red flower, awesome. So I have my 4 different item definitions. Let's create the item stack. So I'm going to the scripts folder, inventory, create C# script, item stack. I do a little bit of cleanup. And as said before, we want it to be just a regular C# class. Awesome. Now, when you use a struct or class as a field on your game objects, so for example, you use somewhere vector2, what will happen? This will be visible in the inspector, so you will be able to adjust this value. If you create your custom class like we do now, and you would try to use it as a field, Unity will not throw an error or something like that, so nothing will happen, but you also won't be able to set those values, you won't be able to even see them in the inspector. So in order to make them visible or settable from the inspector, you have to add the serializable attribute, which is part of the system namespace. So we have that here. So this will sort this for us. And now we need 2 fields. First one will be the item definition. So basically, this will give us the information about which item is in this particular stack. And then, because it's stack, we also want to know how many items are there. So number of items. Awesome. And now, just to make our life a little bit easier and our code a little bit shorter, we want to allow to access directly information from the item. For example, is it stackable or not? Otherwise, basically what would happen, what we try to avoid, we don't want to do something, then item stack, then item, then is stackable, right? Instead of that, what we can do simply something, item stack is stackable. So in order to be able to do that, we simply make a public property, public bool is stackable, and return item is stackable. As easy as that. Now, of course, we want to expose our item definition. So item, and for the number of items, we want to do something a little bit more crazy. So we do that, number of items, and then we'll have getter, which will be very simple, so just returning the number of items. But for setter, we want to do some validation or value adjustment before. So we have set, and in the first line, we want to make sure that the value is positive or 0. So if the value is smaller than 0, then change it to 0, otherwise keep the old value. This will ensure that the value is either positive or 0. And now, before we assign it, we want to check if we have the item. So item is not null, and the item is stackable. Then we want to keep the old value. Otherwise, we want to assign 1. Why is that? Basically, in order to have information about is it stackable or not, it's good to first check if the item is there. That's pretty obvious here. But when we have a stackable item, we don't care how many are there. The important thing is it's positive or 0. That means that we just used the last one and we have to remove it from the inventory. So we'll handle that later. But basically, if it's not stackable, then we want to have just 1. In our slots, we'll always have the item stacks. So for example, it would be strange to have a stack of sorts which are non-stackable and then have their a number of items set to, for example, 7. So this will allow us to basically go around that, to keep there only 1. Okay, and then just to make our life easier later on, I'm going to create also the constructor. Definition, item, int number of items. Awesome. And now I simply want to assign item to the item and number of items. I should use the capital one, right? So the property, not the field, because this way the validation will be in place. And number of items. So this will allow us to conveniently, quickly create the item stacks later on. Okay, now I just realized that we are checking here if the item is not null, but we don't do it in our property is stackable. So let's add that, and then let's replace this whole statement or condition with that. This is much cleaner. Now we'll want to add one extra constructor, empty simple one. Basically, this will allow us to create empty stacks. For example, sometimes we'll want to return information that, for example, we emptied a inventory slot and now the thing that is there or that should be there is empty stack. So this is what will allow us to do that. Okay, it's time to create our game item. I start by creating new script and also create an empty object and call it also game item. I assign the script to it, reset its transform, and now it is in this big pile of icons, so I move it a little bit to the right, so if anything is happening, we can see it clearly. Because our game item will have a visual part, we want to add to it also the sprite renderer. Awesome. Now let's have a look at the script. Of course, we need the reference to our item stack. Imagine how tedious it would be if you would every single time you change the item, for example now, would have to change the sprite renderer, then probably you should also adjust the item name, then there are some issues related to the number of items on stack. Imagine that you would have to sort them out every single time, so you have to do all of that each time. So we're going to automate it. Now first let's have a look at the issue with number of items, because this is pretty interesting. So I'm not sure if you remember that our item stack has a field which is serialized, right? And we have a property on top of that. The problem is what is exposed in the inspector is this field, not the property. Currently there is no way to expose the properties. So that means basically what is happening, this will, the value will be always assigned directly to the number of items instead of number of items property. That means that any type of validation we have will simply not work. So we have to do something about that too. But let's tackle it one step at a time. First, let's focus on setting the right sprite. Okay, we go to our script and create private void setup game object method. At the very beginning, we check if we have the item. If we don't have it, then we simply return. We don't want to adjust anything related, like we don't have item that will be serving as our base, right? So we skip everything. Now, in the first line, we'll want to set the game sprite, as we said. Then what we would like to do is probably update the game object name. And at the very end, we want to tackle also the issue with adjusting number of items. The first one. First, what we can do, we need to get the sprite renderer. So let's do that. So we create serialized field of type sprite renderer. You may be wondering why not just create a private one and get reference to it inside the awake method or start method. And basically this would work if we would like to do this type of stuff inside our game, right? So when we start the game, this will happen. But because we would like this type of things like the setup game object happen also in the inspector, we'll have to basically do it slightly different way. Basically now when the object is over here, the awake and start methods are not called. So basically our sprite renderer field wouldn't be set. So it's much better or easier or foolproof, call it however you want, to just assign it over here straight away. Now we are sure that we have the sprite renderer there. And what we want to do, we create the method, and on the sprite renderer, we simply change the sprite to the item in-game sprite. We do that over here, and now somehow we have to call it, right? So there is this great method called onValidate, which basically is called every single time you adjust some settings on the game object. So what we can simply do, we can just call it over here. Let's see if it works. So we have the planks over here, we have plank selected over here. If we change it to health potion, you see the icon change straight away, which is exactly what we wanted. Now let's update the game object name. I create a method for that. I would like the name to be of form, so the item name, and then in the parentheses I would like to have either the number of item, or if it's not stackable, I would like to have it just display as NL as non-stackable, or NS, non-stackable. So for that, first we can grab the name from the item. So stack item name. Awesome. Then the second thing, we need the number. It may not be number, it may be the NS part. So we do that, number and stack is stackable. So if the item is stackable, then we want the number of items, but we want it as a string, of course. And then if not, we want the NS part. So basically, if the item is stackable, then give me the number of those items. If not, just give me the NS. And now we simply change the game object name to string interpolation, name and number, but we want it in the parentheses. Okay, so this is all we need. We can call it in our method. And now we see we have health potion, not stackable. We change it to planks. We have 0, 6, -3. So there's still this issue that we need to fix. This will be pretty easy, though I'm sure there is a better way to do that. What I'm doing is basically I create a method for that. So adjust the number of items. Basically, what we can do is we can grab the value from the stack, right? So we know the stack has this number of items field, which will give us the underlying value, right? So it will give us this value from the stack. And this is what we assigned, right? And the validation happens when we assign something to number of items, the property with the capital letter. So what we can do, we literally get this value and reassign it back to number of items. It's as simple as that. It's tedious, and as I said, I'm sure there is a better way to do that. But this seems to work very well. So over here, and we already see that over here, if I set 6, it works. If I set 1, it works. If I enter -3, then it changes to 0. Just the name doesn't update. Why is that? Because we need to do that before updating the name. Okay, now we go back over here. We enter 6, works. We enter 0, works. If we change item to health potion, it changes to 1 because the health potion can be only 1 because it is not stackable. Woohoo! So we managed to do this crazy automation. Okay, now let's start to work at picking up the items. So first, in order for the health potion to be detectable by anything, it has to have the collider. So let's add to it the circle collider 2D. Maybe let's increase the size to something like that. Yeah, I think this will work very well. And now in our layer, let's create a layer called items. And let's make sure that our health potion or our game item is in that layer. This will be very important because now we'll go to the edit, project settings, and then in the physics 2D section, we want to disable interaction between the items themselves. So basically this is the thing that you often see in games, that two objects lie next to each other on the ground, they don't collide, sometimes they overlay a little bit and so on, so on. They don't push each other aside and stuff like that, because sometimes this would be pretty difficult to handle. So this is the simplest way of dealing with that problem. Just one thing, make sure that you are in physics 2D, not in the regular physics, because if you change it here, it will not work, basically. So it has to be the physics 2D. Awesome. So we have that. Now on the health potion, we added our circle collider, all good there. But now something has to be able to pick it up. For that, let's create under our little elf character empty game object, and let's call it item detector. Let's add to it circle collider and let's make it slightly bigger. Something like that will work. Oh, maybe a little bit too big. Yeah, that will do it. Now, or maybe even smaller. Yeah, I think this will be all right. Now we'll need simple script. let's go to the inventory system folder and let's create script. And let's call it item collision handler. Let's open it. And now, basically, because it has the collider, we can call on it on trigger, on collision enter 2D method. Boom. So first, from the collision, we try to get the collider. And then on that collider, we try to get component. And now of type game item. Now we store the result in the variable called game item. And we inverse the condition. So if we didn't find anything, then we can simply, we don't need those. We can simply return. Right, so if we didn't find, return, otherwise do something. And now the good thing would be to have actually a method called pick, right? So we could just pick the item up. So let's create it. We go to the game item and let's create a public method called pick and let's make it return the item stack. So sometimes we'll want to know in the future, definitely when we add something to the inventory, we'll want to know what's the item stack there. What is the item and how much of that is there? So what we do, we destroy our game object, so the item that we collided with, and then we simply return the stack we had. You don't have to worry about using the destroy before the return, because the destroy actually waits until the end of the update frame and then destroys the object. So there's no problem with doing that after the destroy call. Now, that means over here, we don't have to do at this moment anything else. We look for the item detector, and on the item detector, we add our new script. If we didn't mess up anything, everything should be working. And as we see, everything works almost as we would like it to. If we look closely, basically what happened, because this is regular collider, right? It interacts with the environment. So when we hit the object, we stop. We don't want that. So basically what we can do, we can change the circle collider to trigger. This will solve this problem, but then also we have to adjust slightly our script. So instead of on collision enter, we use on trigger enter, and then it doesn't accept the collision 2D, but rather collider 2D. Yes, and now we don't have to do collider because we already have it. So those are all the changes we had to do. And if we test it out, we see that the character didn't stop. Awesome. Okay, so let's finally create the inventory. For that, we'll need two scripts: inventory and inventory slot. And we don't want it to be mono behavior, we want it to be regular class. So we can remove that and we can get rid of that too. Now, of course, we'll want the inventory slots to be visible in the inspector, so I'm adding the attribute serializable. Now, this class will hold two pieces of the information. So first one will be the information about the item stack. Let's call it state. And then the second one will be the information if the slot is active or not. So, you know, when we change the slots, basically you can have some keyboard shortcuts to basically highlight certain slot, and basically you want to throw away this item or use it, this type of stuff. So we'll want to track this information too. Now, there is something a little bit crazy, what we want to do. Basically, this component should publish an event or fire an event saying that its state or the active thing, which is also its state, changed. How we do that? First, we add a event to the class. Obviously, we want the event to be public. We use the keyword event. And then, because we want to pass our custom arguments, so we want to give specific pieces of information about what the event is about, we use something called event handler. generic because we'll want to pass the type of our arguments, and then we give the event name. So in our case, let's call it state changed. Now we need to provide a type of arguments we want to do, and we don't have anything like that at this moment, so let's create it. I create a class and call it inventory slot state changed args. A little bit long name, but pretty descriptive, I think. Now, what we do, we wanted to have the information that we want to pass around. So we'll have public item stack new state, which is accessible from outside but suitable only here as read only. So, and public bool active the same way. So basically what this only get does means that we can set it when we initialize the object, so in the constructor, but then we cannot set it from inside or outside the class or object, and others still can read that value but cannot change it, of course. So we create the constructor and give it two arguments. First one will be the item stack and will be called new state, and then boolean active. And then we of course assign those values to the properties we created. So new state true equals new state and active equals active. We have that. We copy the name because it's pretty long, so no sense to write it. And then in our event handler, we just add this type over here. By the way, I have a tutorial about events. I will link it somewhere there. So if you would like to know more details, you can always check that tutorial out. Now, this means that this particular class will be emitting this type of events. So others that are interested in it can subscribe to this event and then get notified about the changes. How do we publish the event? Let's create a method for that and let's call it notify about state change. Awesome. And now we simply use the name of the event, so state changed question mark, which means if there is something, then do the action after dot. If there is nothing, then don't do anything. Why we do that? Basically, sometimes you may have nobody looking for that particular event, nobody interested in it, so why would you publish the event right when there is nothing happening? And I even think that if there is nobody listening for the event, it throws an exception, though don't quote me on that. So we have the event, and now we simply invoke it. And now the invoke method expects us to provide two parameters. First one is the sender, so the object that emits the event or fires the event, and then also the arguments of the type we given over here. So we have new instance of this particular class, and now we provide the information we want to give to listeners. Boom, as easy as that. So now that's all to notify others about change. And now let's do some public properties which will use this method and will basically trigger the notifications. So first we want one, of course, for the whole state. So we want a property of type item stack called state. If we want to get it, we simply return the state. Private set, and then over here we first change the state, and then we notify others about the state change. We do the same thing for the active, so public bool active get active private set, then active equals to the value, and then notify about the state change. Awesome. And then I'm thinking that it would be good to allow others to change the number of items. So for example, if you, use just one item, or I don't know, you fulfill a quest and several items or like multiple items have to be taken. So let's do a property also for that. So let's make public int number of items. And now for getter, we simply return the state's number of items. Easy. For set, we do, and you know what? I think we can just make them public too. So this way, if somebody can change it, someone wants to change it, they will be able to change it directly, and we'll still be notifying everybody after about the change. So nothing bad happening there, I think. And then for set, we do exactly the same thing. So basically we set the state number of items, and then what we do, we notify about the state change. And this will do it, I think. When I'm thinking about it, basically sometimes we also want, there is one extra action we may want to do sometimes on the slot, and that is clear it. So what we may want to do, let's make a method clear. Basically what will happen, we'll change the state to null. And this will also, if we call it this way, nobody will be notified about it. So we want to make sure that we use the capital S state. So we use the property, not the underlying field. Okay, so I think this is pretty solid inventory slot. Now let's go to the actual inventory script. So, okay, our inventory will be the main script. And it will hold two pieces of information. The first one is, of course, the size of the inventory. Let's make it 8 by default. Then, of course, the actual inventory, so the list of inventory slots. Now, this is a little bit problematic because this is a list, so it can grow, it can shrink, and this type of stuff. So basically we would have to look for a lot of different possibilities or different scenarios. So if it's null, so for example, if slot 4 is null, then create it, or maybe player wants to put something in slot 7, and then what to do if we have only first 2 slots. So basically what I found these days is solution is to make some logic which ensures that the slots or maybe the list with inventory slots is always at its own full capacity. So how we do that, we create a method. Let's call it adjust size. And inside of it, we first check if the slots are null. That means nobody yet created inventory list. So in that case, what we do, we simply create new list. And then this line can be shortened to the coalescing assignment operator, which literally means exactly the same thing as the long line there. It's just much shorter. So that's the first part. Now we have a list. Now we have to ensure that it is the right size. So if the list is larger than the requested size, what we need to do, we need to remove some items. We can do that using the remove range method. So we want to remove items starting at the index size, and then how many we want to remove, that's the current count minus the size. And this basically means if, for example, our slots count would be 12 and our size would be 8, that would mean remove items starting at position 8, which is correct. That's 9th item because the indexes start at 0. So that's already too big item, right? So the one that shouldn't be there. And then how many remove including that one? And that means 12 minus 8 equals 4. So remove this and 3 others, which will leave us at the correct size. The same way, if we have less than the requested size, we need to populate it. And we can do that very simply using the add range. And over here, we simply create a new array of inventory slots. And how many we need there? Well, the current size minus the slots count. And once again, why? Because if our count is, for example, 4, maybe let's make it 3, and our size is 8, that means, hey, add to the list 8 minus 8 minus 3, that equals 5 items. So our 3 plus 5 will give us 8, which is the correct number of items. Okay, so let's remove that, and now we'll basically call this method on validate. So private void on validate, adjust size and save it. Now I'm going to assign the inventory to our little elf. Boom, and we see the default was 8 and suddenly I have 8 items. If I change it, it works. Just we don't validate the size, but I don't. Yeah, we could do that, but just let's do not waste time. It's just important because if you enter something negative, then you will get an exception. But I think we can live with that. Okay. One important thing though, when you remove an item, so for example over here, let's put something, and let's have let's say we remove this one. You have to be aware that when you remove item, it is actually removed and the next one is concatenated at the end. So if I press minus here, you see the open one became a number 1. So this is pretty important to remember, because if you do some crazy stuff, this may introduce some bugs. So just keep that in mind. Okay, so let's finally add the item to our inventory. First of all, we need a method to decide if we can add the item, right? So if the inventory has space for that. So first, let's create a public boolean is full method. So what we'll do here, we'll compare the number of slots that have an item with the size of the inventory. So for that, we have to count items in our inventory. So if I try to use now count, it will not use the link expression, but rather, so if I do that and do x something, you see I'm getting an error because it doesn't know what is happening. That's not the count I want to use. This count is basically this one, which just simply shows the number. And you see this is not even a method. So in order for it to work, I need a link expression. So for that, the simplest way is to basically add using system link. And now we'll be able to add slots and then count. And now, for example, I can do slot that has item. Would be good to have something like that, right? So let's move back to the inventory slot and let's add another property, public bool has item, and this will basically return state a question mark. So if there is no state, that means it's null, so obviously it doesn't have an item, or then check its item because maybe it still doesn't have it. So this one not null, so we want to check if both of them are not null, and we can do that this way. So now we have has item method. Awesome. So this counts as basically this is lambda expression saying that basically this is equivalent to a method public bool something, because this one doesn't have name as we see. So this would be something like inventory slot and then return slot has item, right? So we could literally, instead of doing that line here, do that. And yeah, you see it literally accepts it without any problem, because this is literally equivalent. If you have a one line expression, you can move it even you can shorten it with arrow, right? So this literally means the same thing. So something method takes this parameter and then returns this one. But then if you again have just this part and you are not interested in making it reusable, you can simply do slot and then slot has item, and then not bigger than 2, but then bigger or equal to size. It should never be bigger, but you know, it never hurts to check it. So this means if we have more items with, if we have more slots with items than size, that means it's full. But now that's not always true for us, right? Because we may be full, but we may be still able to accept items. For example, when we have stacks, right? So for example, you have 5 nails and you want another 5, and you can combine them without any problem, even though you don't have empty inventory slot. So for that, let's create another method and call it can accept item. And then we want to know like what item we try to add. And for that, first would be good to check if we have stack with that item already in place. How we can do that? Would be good to have a method that will allow us to search for stacks, right? Or search in general for items or slots with given item. So let's create one. This one will be private inventory slot, because we want to return inventory with that given item. And now find slot item definition. And we want to check which, we want to know which item we are searching for, of course. And then let's make another parameter called only stackable, which will be by default false. Basically what we'll do, we'll check if, for example, we can search only for stackables. So we have 3 health potions in different slots, and then we have 1 stack of nails and 1 stack of planks. So it will return only those 2 with items that can be stacked, yes. And if we provide only, for example, we ask only nails, then we'll search only stackable nails. I think you know what I mean. So over here, we return slots first or default, which will return first one, or in case of class, so which the inventory slot is, null if it didn't find anything. Slot item, and we need to compare it to the item we are asking about, but then we see we don't have that property on our slot. So let's change it, public, or maybe let's add it. Item definition, item, and this will return simply the state item. Awesome. So slot.item now works, beautiful. But this takes into consideration only the first part. Let's also add the other part. And now a little bit of magic. First we have to check if the item is stackable. And then if it is not stackable, we have to check if we are not looking for stackables. So basically this condition always have to be true, right? So if the items do not match, then no sense, this slot is definitely not the one we are looking for. And then if the item matches and the item is stackable, then great. But if it is not stackable, then the other condition has to be true. So if the item is not stackable, that means this has to be false, because we inverted, right? So basically what it will do is, let's assume for now that always the items match. So let's say, for example, we are looking for planks, and of course we look only for stackables, right? So in that case, the planks are stackable. So the first condition is true. So the OR condition doesn't evaluate the other one. Doesn't care because the first one was true. So this one. Now, if we are looking for a health potion and the condition is true, the first one will be false, right? And now, if we provided here true, the OR condition will evaluate it, hoping that maybe it is true, and it inverts the value. So if we entered true, it will be false. So those both return false, and that means the slot will not be returned. Now, if we, for example, look for health potion, which is not stackable, and we left it at false, so the default, so the first condition is still false, but the second one, here false, is inversed and changes to true. And then that means it's true and we can return slot. Okay, so we have that. So first we want to check if we have any slot that can accept this particular stackable, in case the item is stackable, right? Slot with stackable item. And now find slot, of course, the item we are looking for. And then we are interested only in stackables. And now we return if not full or slot with stackable item not null. Basically what it means, can I accept the item? Yes, if the inventory is not full, of course, because that means I have a empty slot, which is great. If it's full, so this evaluates to false, because is full returns true, this turns to false, so we go to check the other condition. Slot with stackable item is not null, so it means we found a slot that can accept this item, which is stackable. Whee! So that means I can accept it. If this would be full and we didn't find any slot, then we cannot accept the item. As simple as that. Okay, it's time to finally add the add item method. Let's make it public, let's make it return the item stack, and also accept item stack as a parameter. Awesome. You may be wondering why I'm returning the item stack. The reason is, in this particular script, I have this convention that after the operation, so after adding or removing the item, I want to return to the developer or the user of the class the state of a particular slot. This is very useful for things like questing system and maybe logging and so on. So it's almost no effort, but it has a lot of potential use cases. So we have that. And now the first thing we want to do is we may want to try to find a slot that could accept our item in case it is stackable. Over here, let's call it slightly differently, relevant slot, because we'll do some other stuff later on, and it not always may be the slot for stackable object, but at this point it is. So, and now we want to do simple check. So is full, so if our inventory is full and our relevant slot is null, that means, oops, no space, right? And we should do something about it. So the inventory itself doesn't handle adding, right? So it allows you to add stuff to it, but it's not calling this method itself, right? It's public method. So the other place or the other script has to ensure that it can actually add the object or item to the inventory. And we already created methods for that. For example, can accept item, right? So in case somebody forgot to check this type of stuff and try to add item even when there is no space, we should simply throw an exception. So how do we create an exception? First, we create a class. Let's call it inventory exception. Now, if we want something to be exception, it has to extend exception type from the system namespace. The exception has some constructors which we can take advantage of. So, for example, one that accepts a string and sets a message of the exception to be that string. So how do we allow our inventory exception to use it? Basically, we create our own constructor and we say it to use the constructor with the same parameter on the base object. And of course we have to have the parentheses. But this is pretty boring because of course we can set a message, but it's not very informative, right? So in case of exception or message like inventory is full, okay, this is pretty clear, we probably try to add something. But there might be situations when we call something like, for example, invalid item, right? And then invalid item when. So in order to make it more user-friendly or developer-friendly, or actually even tester-friendly. So if you, for example, if your game crashes with an exception and they see that exception, they can basically report to you, hey, I got this and this, and you know, this always gives you some extra information. So what would be a nice way of setting also the operation of that we try to do? So in my opinion, we can create a enum called inventory operation and give it two values, add and remove. And now we can store it inside our exception. So public inventory operation and public getter. So this will make it read only, so we can set it over here in the constructor. So first we'll need a parameter of that type, and now we can simply set the operation the other way around. We can set the operation to operation. Okay, now we have it on the exception. Would be good to have it as a part of a message. So let's use the power of string interpolation and give additional piece of information over here. So operation, error, colon, and now message. So in case we call now the exception or throw the exception with two parameters, let's say add and inventory is full, we'll receive a message add error, inventory is full, which I think already gives us some more information. So how do we throw it? Very easy. We go back to our inventory, and over here we use the throw statement. We create a new instance of this exception with add operation parameter and message inventory is full. Awesome. So if the inventory is full, we have handled the situation. Now we have two more scenarios. So the first one is we found a relevant slot. That means the item is stackable and we have place for it. So in that case, it's extremely easy. We just take the number of items and increase it by the number of items from the stack that we provided in the parameters, right? So there is already something in that slot. It has, let's say 5, and we add new items to it. If there was 3, this will be 3, and we'll have in slot 8. But then there is also a situation where we didn't find a slot. That means we have space in the inventory, but we don't have that item in the inventory yet, or the item is not stackable. So then we look for the first empty slot, and this is also pretty easy. So we, on our slots list, we call the first method. We don't have to do first or default. We know we have something because the inventory is not full, so we have empty space, we are sure of that. So slots first, and now slot that doesn't have an item. As easy as that. So we have a slot, and now in order to put something there, we simply set its space to the item stack, and awesome. Now we would like to return it, right? So we want to return the state of the relevant slot. So we simply do that. Awesome. We have method to add an item to our inventory. Let's now open the item collision handler, and let's actually add the item to the inventory. So first we'll need the reference to our inventory. And let's grab it in the awake method. So I'm not sure you remember, but the item detector is actually a child of our little elf, right? So the inventory is over here and the item collision handler is on the child. So what we have to do when we get the script, we actually want to get it from parent. And now we provide type inventory and we have it. Now we simply call inventory at item with the stack returned by the game item. Awesome. Let's do a quick round of testing. So our little elf has the inventory. Let's open it. Let's walk to the object and we see that the object is now in the inventory. Let's test some other scenarios. So first let's change the inventory size to 2, so we have much less space over here. And let's turn the game item into the prefab. So folder for that, prefabs. Awesome. And now, first thing we have to do is to remove the item, so the name doesn't change. We can zero the number of the items. And for the sprite, I think we can select something like more blunt, so something that doesn't suggest a particular item. This small arrowhead will do. And let's call it game item. Now, in order to turn it into prefab, I just drag and drop it into the project window. So I have prefab. Let's turn it back to the health potion. Awesome, as easy as that. By the way, there is this warning set once we change the sprites, and I'm very interested in why it is happening. To be fair, I have no idea. If you have, please let me know in the comment. I will be really grateful. So let's leave it as a health potion and let's create some other game objects or game items. So another health potion and maybe planks and another planks. And here let's have 5 of them and here let's have 3 of them. And now let's test it out. And first, we have a look at the little elf inventory. We have 2 slots which are empty. We pick up health potion, everything works as expected. We grab planks, 3 as expected. In the other stack we have 5. Now we have 8, awesome. And what happens if we try to grab the other health potion? It just disappeared and we have received the exception as expected. At error, inventory is full. So now, being a good developers, we have to do something about it. So let's go back to the script. We know what is happening. The inventory was full, but we didn't check if there is any space. Let's use the canAcceptItem method inside our item collision handler. So over here, we have to extend this condition. So the first condition is if the collider didn't have a game object, game item script, then return. And now we want to make it if the collider doesn't have the game item script or we cannot accept the item. So, or can accept on inventory. We of course inverse it because we want to stop the execution where we cannot accept it. And now somehow we have to provide here the item stack. So game item, and now, whoops, turns out we don't have stack available for us. So we go to game item and under the sprite renderer, we create a property. Public item stack, stack, and return stack. And now we have it. This should be all. Let's just add enter over here and let's test it. Clear the exception and start the game. So first, second object, awesome. And now we are not picking up items as expected and we have no exceptions. Let's test another way around. So we first grab planks, awesome. We grab health potion and the second one. Also everything as expected, awesome. Okay, it's time to create the visual part of our inventory. For that, we'll need 2 scripts. Inventory. Let's create another folder and call it UI. Inside of it, let's create 2 scripts. First one, the UI inventory, and one for our slots. So UI inventory slot. So I'm starting by adding the canvas and changing some settings. So I would like it to scale with screen size, and I would like it to be mainly influenced by the height. So maybe 75% height. Awesome. That will do it. Now on my canvas, I want to add another game object and call it inventory. I change its anchor preset. I'm clicking on this over here, pressing Shift and Alt, and clicking over here. So it's stretched at the very bottom. Okay, this looks all right. Now what I want to do inside of it, I want to create my first inventory slot. So I go to UI, image, inventory slot. Awesome. And I change its sprite, make it smaller, something like that. I think looks all right. Now, if I copy and paste it several times, you see nothing is happening, they occupy the same position, and so on, so on. So on my inventory, I'm going to add two different components. First one will be the canvas group. This has nothing to do with the position of the items, but basically what it will allow me to do, in case we would like to hide and show the UI, we can do that using this canvas group. So this is pretty convenient way of doing that. And then the second item I'm going to add is the horizontal layout group. Suddenly you see they are nicely spread. I would say even a little bit too much. So in order to keep them in one place, I'm going to uncheck the child force expand width. Awesome. Now I'm changing their position to be in the middle center, and would be good to have some spacing around them. I think 10 will do it. Let's have a look how it will look in the game. I think this is a little bit big, so in order to adjust that, I'm going to go to the inventory, change the height to maybe 80, and then change the slot size to something like 70 maybe, or maybe even 60. Then remove those two and paste those two. Let's see now. Awesome. That looks much, much better. So I can remove those two little guys over here and now focus on this one. So I have my inventory slot. Inside of it, I need another image called item icon. I want the image to occupy the whole square. Let's give it a item icon. So for example, this one, and I see it is obviously too big. So what I'm going to do is I'm going to give it a border around from each side, maybe 10 pixels. 10 is too much, so maybe 8 from each direction. And I see this looks all right. Now there is one more setting I have to set. So basically for this one, it looks all right because this sprite is squared. But for example, I have one that it's not. So for example, this one, those are nails and they are a little bit stretched. So in order to fix that, I set this preserve aspect. So you see now basically the image will keep its aspect ratio. So now I can select any item and they will all look good. Yay! Awesome. So I have that, and now also I need the text to show how many items are there. So I'm selecting the UI text Mesh Pro. I need to import the essentials because I haven't done that before in this project. I close it, and now once again I select the preset, holding Shift and Alt to occupy the whole space. Then I change the text to something like maybe 13, make it bold, make it much smaller, so maybe something like 25. Yeah, looks great. And now I'm moving to the right, to the bottom. And for my liking, it is a little bit too much to the right. So I'm going to adjust manually that. And maybe also the bottom one. Nice. Now let's use the de-allate a little bit so we can make it a little bit bigger, and now use the outline to make it have the outline. So something like that will do. I think the text is still a little bit too big. Let me check in game. Yeah, I think it's a little bit too big, so maybe let's grab that. Let's change the size to, not that. Let's change that to 20. And let's make it even bigger. So let's use that. And then that. Yeah, I think that's a little bit better. Awesome. I like it. So now let's change the object name to number of items. And of course, our inventory slot has to have the script inventory slot. And let's straight away assign the inventory script to the inventory object. Now, I think actually we may need one more thing, which is the active slot indicator. So what I'm going to do, I'm going to click right, UI, image once again, call it active indicator. I'm going to make it be attached to the top of the object, so over here. Now I'm going to change its sprite to the small arrow and click set native space to make it smaller. Now I see that it's still too big, so I'm selecting this constraint proportions, so it scales in all axes together, and when it's the size I like, I just move it to the top. How does it look in the game? Beautiful. It's time to have a look at the script. Okay, so let's open the inventory UI inventory script. We need some fields. So first one, for something we don't have yet, we'll create it in a second. That will be the prefab of the inventory slot. So private game object, and over here inventory slot prefab. Awesome. Then we'll need another serialized field, this time for the inventory that will be displaying. This way we can just drag and drop the player or another player, so you know, it's a little bit more extensible. I think we may want to sometimes display, I don't know, chest or something. Of course, maybe not in this particular UI, but in general, I think this is good practice to keep it extensible. Then another serialized field, this time for the list of our UI inventory slots. Let's call it slots, and let's import the collections generic. Awesome. So we have that. And I think our UI inventory slots will want later on to use the inventory from us, from the parent. So maybe let's do that. Inventory, and let's return inventory. Awesome. Now we'll need the slot because we'll want to create a small automation. Imagine that you change the inventory size on the elf, and now imagine that each time you have also to manually create those UI slots on UI. That would be terrible. So in order to not do that manually, we'll start by creating or turning this inventory slot into the prefab. So once again, I select it and drag and drop it into my prefabs folder. Now on the inventory, I have the inventory script, and first I set the prefab. Awesome. And then I also set the inventory. So I drag and drop the little elf here. Awesome. And now let's create our automation. We'll do it slightly differently than previously. We won't use the onValidation because I would like to show you another method. So let's start by creating a method called initialize inventory UI. Awesome. Okay, so if we didn't assign inventory, so if inventory is null, or we didn't assign the prefab, we want to return. So we don't do anything. Otherwise, we create new list of slots, and the size of that list will be basically our inventory size. I see that we don't expose the size apparently. So let's go there and check that. Looks like that's true. So over here, let's just go public int size, size, done, beautiful. So we go back to UI inventory, and now we have size, awesome. Now we loop, depending on the size on the inventory, of course. So we do that, and then increase I, awesome. So now, first we want to instantiate the prefab, and it turns out when you use the regular instantiate method, you don't instantiate the prefab, so it doesn't stay as a prefab, it stays, it's creating just a regular game object. So to keep it as a prefab, we will use the prefab utility, and now the instantiate prefab method. So we provided the prefab we want to create an instance of, and now on the UI slot, on its transform, of course it has to be as game object, beautiful. Now on its transform, we want to set parent to transform, and then as the second parameter we want to provide false. Basically, the second parameter will ensure that the scaling and everything that we set up on prefab is basically respected and is taken into consideration the way we would like it. We want to grab from the UI slot the script that we have there, script, and now UI slot get component and UI inventory slot. Whoops, awesome. So we have that. At this moment we don't have anything there yet, so we'll leave some space over here because we'll be adding some magic later on. So here we just add the slot to the slot list. So slots add UI slot script, awesome. And now we'll add a attribute over here. So the attribute will be context menu, and now we'll call it initialize inventory. So what this will do, basically, as you see, this method should only spawn for us the inventory slots, so there shouldn't be much happening. So let's see if that works. So I'm removing this one. Also, I wanted to do it such a way that it first clears the inventory and then recreates it, but I had problems with removing the prefabs because the destroy and destroyed immediate methods complained, so I didn't achieve that. If you know a convenient way of deleting prefab in the inspector, of course from the script, please let me know. Okay, so I'm removing that, and over here on my UI inventory script, I have this new option, initialize inventory. If I click it, boom, the slots have been created as expected. So awesome, this is pretty handy. So we see that they don't have the right settings. So let us fix that now. To do that, we have to have a look at our UI inventory slot script. So let's open it, and now we need again some references. So of course, in order to connect it to the right slot, we need to connect it to the inventory. Inventory, awesome. Then we need to know at what index is the slot that we are interested in. Inventory slot index, awesome. The next information, or not even one, but several ones, are the items or the references to the game object, so UI elements like image, text, and so on, so we can update them. So of course, first we have the image for the item icon, and now you have to be careful, you have to import the correct one. So import type, and you see over here I have Unity Engine UI image. Boom, we have that. Then we have another image, which is the active indicator. So private image active indicator, boom, beautiful. And then last reference we need is the text for the number of items. So private TMP, so text mesh pro underscore text, and over here number of items. And of course we have to import this one. Here it's easy, nothing to select really. And when we connect to the inventory, we actually want to store the slot that we are connected to. So let's just create a field for that. So inventory slot. Awesome. And now we have to have a way of assigning a slot, of connecting somehow the right slot. Let's create a method for that. So private void assign slot. And the first thing, of course, we have to check if we have inventory. If we don't have inventory, what we do, we try to get it from our parent. So we first get the component from the parent, which is the UI inventory, and we know that it has this beautiful field exposed for us, inventory, or rather property. Awesome. And now, once we grabbed that inventory, what we want to do, we want to assign the slot from that inventory. So inventory slots, and now inventory slot index. And I see that we don't expose it from the inventory. I was sure we do that. So let me have a look. No, we don't. So public list inventory slots, and then slots. I will do it. Beautiful. So let's go back to our inventory slot. Awesome. So we want to select one at the given index, and the index is stored over here. We of course need to grab this information while we are assigning the slot. So for that, let's create parameter. So int and slot index. So now, before we do any of that, we can also do the inventory slot index. Done. Beautiful. So we have that. And now you remember that on the inventory slot, we have our event state changed. So of course we want to be notified when the state changes, so we can update our inventory slot, right? So how it looks like. So for that, let's subscribe to that event. So slot dot, and now state changed. So we see we have this event over here, and now we add ourselves to it. We add our method to it. Now we have to think about a method because we don't have it yet. So let's just quickly create a placeholder method for that for a moment. So on state changed, of course, first is sender. So basically that's the, you see when we invoke the event, right? We have two parameters. The first one is the sender, as we said, and the second one are the arguments. So over here, the first one again is sender, and then the second one are the arguments. So inventory slot change, slot state changed args. Awesome, args. And we have a method. For now, we don't do anything. Awesome. So we just put it over here, semicolon, and over here we are done. Now there is something interesting. So if we assign it first time, right? So if we assign the slot first time, that's great. But if we assign the slot previously, so there was already slot, that means we are already subscribed to another event. So we have to unsubscribe. And the best place to do that will be just over here before we assign the new index, or before we grab, even before we grab new slot, right? So this doesn't matter that much. The important thing is that we check if the slot is not null. So if the slot is not null, before we assign new slot, what we do, we unsubscribe from the event on the same, using the same method. Awesome. So very nice. We can use that already in the UI inventory, right? So over here, we have the index over here. So this is pretty convenient. So we can simply do UI slot script, assign slot, and the slot index. This is complaining because we should make it public. So let's make it public. Now Great that we subscribe and assign slot, but this really doesn't do anything, right? We don't update any visual part. So let's handle that now. Let's create a method. Should we make it public? No, let's make it private for now. So private void update view state. And to make our life easier, we'll basically make it have the parameters that will match the arguments from the event, because we'll want it to use it there as well. So we know we have the item stack. So that's the first thing, right? So that will be state. And then we have the information if it should be active or not. Awesome. And in that case, first, we want to set the active indicator, right? So we have this little arrow over there. And we simply want to show it or do not show it depending on the information if we are active or not. So if the slot is active, we want the arrow to be visible. Great. Then we want to make some helper variables. So first one will be the item that we can grab from state. And we do it using the question mark over here. So this way, if the state came null for some reason, we'll receive null and not the null pointer exception. So if this is null or this is null, we'll have null over here, and this is very good. Now we create another one called hasItem, which will be simple boolean checking if the item is null or not. So if it has item, that means the item is not null, as simple as that. Then another one is stackable, and here we'll cheat a little bit, because first we'll check if it has item, because this way we'll not receive the null pointer exception while we check if the item is stackable. So if we don't have an item, we'll receive false, and that's also fine for us. We don't care, because obviously if we don't have item, it cannot be stackable, right? Awesome, awesome, awesome. Now, first we have the item icon, which now we want to enable or disable depending on the information if we have an item. If we have item, of course, we'll want the icon to be there. And the same thing for the text. So number of items enabled. And now the information is slightly different. We'll use the is stackable over here, right? Because if we have item, so we may have an item, for example, health potion, and display it, but we'll also know that if it's not stackable, it always will be 1, right? So no sense to show the number. So basically we can hide it if it's not stackable. Awesome. If we don't have item, awesome, we can simply return. So if we don't have item, we don't do anything else. We've hidden what we wanted, done, beautiful. But if we have an item, then we of course want to set the sprite to the right one. So we can grab it from the item. So UI sprite, awesome. And then if the item is stackable, we can set the number of items set text to the state number of items, and now to string, because it requires us to provide a string. Awesome. And this is all I think here. If we put it over here at the very end, and we use some information. So we have slot here, so we could use slot state, and we could use the slot active. This should be working already when we assign the slots. So let's check that. So for testing purpose, I'm moving over here. I'm deleting all the slots. On our little elf, in the first slot, I put the health potion. In the second one, I put 5 planks. And let's see what will happen. Inventory, inventory, initialize inventory. We have an exception. Of course, we have an exception because we have the slot script, but we don't have any variables assigned. So for those ones, let's first assign the references. So item icon, number of items, and then active indicator. So basically, because they are all combined together, right? So they are part of this prefab. Once we save it on prefab, Unity will understand that those items, if we have references to them on the parent, right? So on this one, it should keep it like related to the prefab. So it's not like, we create 5 prefabs and they all will be related to the first one. No, it will be basically each one will have its own references. But now we have to store it. So in order to save this information, we click on the prefab, and here in the override section, we select the UI inventory slot because that's what we want to override. And we click apply all. Beautiful. So now we delete this slot once again and initialize inventory, and you see it's working. We have it. Beautiful. Let's go back to our UI inventory slot script. So over here we have our onState change method, which reacts to the events triggered by the actual slots, but we don't do anything there. So we of course would like to call the update view state method. So let's paste it. And then, because we make it, we designed it to work easily with the arcs, we can simply pass the information from the arcs directly to it. Awesome. But now there is a small problem. And I think what is happening, basically during the assignment of slot in the inspector, basically the subscription to the events is not propagated to the game. So basically we have to make sure that we are resubscribed during the start of the game. So the easiest way to ensure that all of those actions happen is basically to call the method on start. So private void start, and we can simply call the assign slot with the inventory slot index that we already have. Okay, and this should be enough to make it work with the events. So over here we again have our small inventory with already 2 items which are displayed nicely when we start the game. And now let's see if the UI is updating correctly. So I'm collecting planks and the number is changing as expected. Then I grab the health potions and they are also added to the inventory. Awesome. Now let's revisit our inventory script. So there are a few things we have to add. First of all, we don't have any way of steering which inventory slot is active. So let's start by doing that because this will be pretty simple. So first of all, we need a variable or rather field to store information which slot is active, right? So we have active slot index. Awesome. And now would be good to have a property on top of it. So public int active slot index, and now when we want to get it, we simply return the active slot index, as simple as that. But when we want to set it, and here let's do some magic, so let's make it private set, so we can do it only from within the class. So in the first line, what we want to do, we want to deactivate the old active index, right? So before we change the index, we want to ensure that this one is deactivated. Then we want to ensure that the active slot index has the right value. So what I mean by that, we have, for example, 8 inventory slots, right? And we can, at certain point, if we try to go next, we reach the 9th one, or we go previous, and we go to -1, right? So we want them to basically loop around. For that, we can do simple checks. So if the value is smaller than 0, then we basically move it to the back, so to the last valid index, which is size -1. Otherwise, we want to use value modulo size. This is very simple. It's looking daunting, but in case you are wondering how it works, basically modulo gives you the rest from division operation, right? So for example, if we have 5 and we divide it by, if we do modulo 4, the result will be 1, right? Not because there is 1, maybe let's do different example. So when we have 9 and we do modulo 4, the result will be 1, right? Because we have 2 fulls, and after that, so once we do 2 times 4, we have 8, and 9 minus 8 equals 1. So that's how modulo works. Now, how this one works is basically when we have, for example, 0, so first slot, right? And let's assume for now that the size of the inventory is equal to 3. So just so it's not too long. So we have index 0 and we change it to 1, right? So it changes to 1. So before we assign it, we do modulo size. So what is happening? That's basically giving us back 1. Why? Because 3 times 0, right? Because we don't have any 3's in 1, gives us 0, and 1 minus 0 equals 1. As simple as that. Then we move from 1 to 2. Then we do 2 modulo 3. This gives us a result 2. Why? Because 3 times 0, once again, why 0? Because in 2's we don't have any 3, right? So that gives us again 2 minus 0 equals 2. Then for 2 to 3, I think you know where I'm going. This will be 3 divided by 3. Here the result will be 0. So we went back to the very beginning. Why? Because 3 times 1, because in 3 we have 1 3, right? So that's 3. And then 3 minus 3 equals 0. So that's the operation. So that's how it works. And then again, because we went back to 0, then right when we assign from 0, when we change from 0 to 1, we again at this stage. So this is very convenient, a very nice way of doing that. So we have that. And then what we need to do, once we have the new slot index, we basically want to activate that slot. So here is very, very simple. Now, because we made it private, it would be good to have a method which will allow us to activate a slot, right? So just scroll down, maybe over here. Yeah, that will do it. Let's make a method public void activate slot and then int at index. And this will make active slot index equals at index. So basically this will use our property and will basically adjust the value. So in case something, there might be some strange behavior because sometimes somebody may put random values like 23 or something and it will just activate the random slot, but you know, we assume that our users are generally pretty smart. They're not. Yes, so we have that and this will be used by something. Now, before we do that, let me add a little bit out of context some other useful methods because our inventory at this moment is pretty raw, right? So we have only add item, we don't have any ways to remove, we don't have any way to check if we have something inside of the inventory. And those are usually the things that you will want to do, so it's good to have those methods over here. We'll add a method public bool has item, and now it will have two parameters. First will be the item stack and the second one will be optional called check number of items, and let's by default make it to false. So this method will allow us to check two things. First one, if we have particular item in the inventory. So for example, NPC wants to know if you have a key, NPC wants to know if you have a health potion, NPC wants to know if you have a plank, but important, if you have any plank, not if you have 20 planks. So that's when this will be set to false. But if the NPC would like to know, do you have 20 planks, right? Then you will have to check this one to true, right? You will have to set it to true. And then it will check also the number. So first thing first, we need to get a slot containing potential item. So item slot equals find slot with the given number. So item stack item, boom. And now first situation, very simple. If the item slot equals null, well, easy, then it means we don't have it. Now if we have something in inventory, it really depends if we want to check the number or not. So if we want to check the number of items, Then we have two scenarios. First, we want to count how many of the non-stackable items we have, right? So first, if our item stack item is not stackable, or maybe let's handle that first for the stackables. So if it's stackable, then it's as easy as checking if the item slot number of items is larger or equal than provided item stack number of items, right? So we just return this information. If the item is not stackable, we have to count them. We basically use our slots and we count how many we have. So where the slot item equals the item stack item. This gives us a number, and once again we have to make it larger or equal to the number of items. And because we return, then will not continue, so we don't have to put there else. And now we have one more scenario. So if we have an item slot and we don't check the number, it simply means we have the item. So we simply return true. Boom. So this is the has item. Now I see we can simplify it, invert if. Yes, so you see, if we don't check the number of items, we return. It's just inverted the logic. Nothing changed there from the logical point of view. It's just, I think, a little bit shorter and has the smaller nesting. So this is pretty nice. Okay, what we want then? We want to be able to remove items. So the first way, the simplest way, would be to simply clear the slot, right? So for example, something may be stolen or something may be destroyed, this type of stuff, right? So we don't care how many things there were, we just destroy the whole stack, right? So, or the whole slot. So for that, we just create a method called clear slot, and then we want to know at which index. And then our slots have already method called clear. As simple as that. Now, sometimes we may want to actually care about the result, right? So not only clear the slot, but also ensure that there was something before, and we may want, for example, to return the information that the stack is now empty, and so on, so on. So for that, let's create a method called remove item. And it will have two parameters. First one will be at index, so which place we want to remove. And then we'll want information, like for example, when we throw something from the inventory, if we should spawn the item or not. And by default, let's do it not. So for example, when the item is stolen from us and the NPC wants to keep it, for example. So first of all, we have to check if given slot has item, right? Because if we want to remove something and it's not there, then might be some implications or complications and so on, so on. So for that, let's just throw our beautiful exception. So throw new inventory exception with operation remove and the information that the slot is empty. Awesome. Otherwise, we will want to spawn the item, right? We want to know if we should spawn the item. We'll handle that in a while. But then, of course, we want to clear the slot. And as we discussed, when we do operation on a particular slot, we want to notify the user or the developer how much stuff left there. So for that, we simply return new stack. So as simple as that. And now we want one more very interesting option, which is again removing item, but not by a index, but by an amount. So public item stack remove item stack item stack. Awesome. So first of all, we want to find a slot that contains this item. So item slot item stack item. Easy. So now we have slot. if we didn't find anything, then we notify the user again using the exception that, hey, you tried to remove something, but this item is not there. So basically what the developer should do before that, before removing the item from the inventory, he or she should check if we have this item. So this is very important. Then we also need to verify the number of items, right? So basically, if the item in that particular slot is stackable and we have less of it, so number of items, then we request it. We also throw an exception. So we do that. And let's just put a message, not enough items. Boom. Then, and only then, because those ifs handle the exceptions, so the wrong conditions. Now and only now, we basically remove the items. So item slot, number of items, item stack, number of items. Beautiful. So now we have two different situations. So first we may have item that is stackable. So item stackable. Awesome. And there is more items in that stack. So more items left. Then we simply return what is left. Right, so at this moment we'll know, so the developer will know in some other place that, okay, he still has some left of something. So he can do something with this information. There is also second situation, which is nothing left, right? So the item is either not stackable, so we took the instance that we wanted to take, or basically we zeroed it completely. So in this situation, we just want to clear the slot. So item slot, clear, boom. And then we simply return the new item stack, empty one. And this gives us, I think, all the things that we need. We'll also have to get back here to spawn the item, but we'll do that in a moment. So in order to know which item we want to remove, we have to finish setting up the active slot. So for that, first of all, still inside the inventory, we want to add the awake method. So we scroll somewhere up and we go with private void awake. Inside of that awake, we want to check if size of the inventory is larger than 0, and then if it is, then set the slot at 0 as the active. So at this moment we should have the first slot active. Awesome. We see that the white arrow appeared over here, but now we don't have any way to change it. So let's add that. For that we'll need another script, which we'll call inventory input handler. Let's add that script to our little elf. So let's hide this one. Inventory input handler, somewhere here, this one. Okay, and now we'll use it with the new input system. It will be very easy to adjust for the regular input system, so don't worry about that. I think the ideas, if you went so far and you understood everything or most of it, I think this won't be a problem. But just want to let you know that I have the input actions, and basically I have those three are relevant for us. So I have previous item under the Q button, next item under the E button, and then I have action called throw item at the F button. Now, some of you will hate it, but I have my own way of working with the new input system, which is very convenient. It might not follow the best practices, but seriously, it is so convenient that I just cannot resign from it. So basically, I auto-generate the input class as regular. So I just check the checkbox on the input asset, right? And then obviously I set the name, I set the namespace. Here nothing is that relevant. But then what I do, I create another class, which basically what is happening over here. So this auto-generated class is partial. So it means we can basically create another class that will have the partial keyword, right? So we'll be able to create another input actions using the partial keyword, and basically the methods there will combine into one class. So I'm using that over here. So you see I have another input actions class marked as partial. So I'm extending that class without modifying the auto-generated one, because obviously if I would modify the auto-generated one, that would be, you know, tough, because every single time I add action, it would overwrite my changes. So this doesn't make sense. So I have something like a half singleton. It's not singleton, but basically what is happening, I have static instance of the input actions. And basically when I try to get it first time, I create new instance of the input actions and I straight away enable it. Then I simply return it. Then every single time, wherever I want, if I access the instance, then I will be getting the same input actions. This is very, very convenient. And at the same time, it doesn't lock me from writing unit test or anything like that. It does a little bit for that, right? But the thing is, I'm still able to create the regular instances of input actions anywhere I want without any problem. So now, how do I use it? We created our class. Let's open it. So inventory input handler. Because I have it on the same item as the inventory, I can just make a reference to inventory. So inventory field, easy, and then a private void awake to grab inventory script and store it over here. So inventory get component, nothing magical here, simple. Why I need that is because on the inventory we have our method to set the active index, right? So everything should be handled now, so we shouldn't be needing to add anything else on the inventory. We just need to change the index, hopefully. So in order to do that, we can subscribe to the events from the my input actions on enable, and then on disable unsubscribe them. So let's create those two methods. And of course, before we subscribe, we need those three methods. They will be extremely simple. So first one will be on throw item, input actions input action dot callback context. So callback context. This one will be creating a little bit later, but just I want to have it so we can also subscribe it straight away, so we won't have to worry about that later. Then we have also the on next item, input action callback context, and on this one it's pretty easy. So inventory activate slot, and now basically I want to use the active slot index plus 1. So that's how I get the next number. For the previous one, it's as simple as just changing here to the previous and here to -1. So we have those three methods, and now let's subscribe them. So input actions, that's my class, the magical one I showed you in a moment. Instance, game input map, right? And then inside of it, I have the throw item action, and when it's performed, I want to subscribe to it with on throw item. Then I just copy paste it 3 times, on next item, on previous item, and of course I need to change the event. So on next item and on previous item, and the same over here. So in order to unsubscribe, I simply change this to -. So basically By the way, if you didn't work with new input system, I will leave a link somewhere on the top, because I have several tutorials about it. So I think it's good thing to know, and it's much better than the old input system. Seriously, I love it. Okay, so we have that. I go back here and let's test if it works, because as I said, we shouldn't need to change anything else. Yay, let's go over, yay, we go back, and let's go below, we go back. Awesome. So over here everything works. In case you are wondering how is it possible that it works out of the box, a very quick reminder of what is happening there. So once the action is happening, once I have input, for example for the next for the activating next slot, I set the active slot index inside the inventory using the method, right? Then over here we have the property which deactivates the previous one and activates the new one. We activate a slot, so our inventory slot, once its activity is changed, we send the notification about state change to the UI inventory slots. They basically over here subscribe to that event, right? So once we were assigning the slot, they subscribe to that event with this particular method, onStateChanged. And this method calls another method, which then, as a result, updates the active marker over here. I hope everything is clear. So at this moment, only last thing left, which is removing the item and throwing it on the floor. And the fun part is that we have already methods for removing items from the inventory, right? So we created them before. So we have those, awesome. And we also have already information about the active slot. So this is all we need to remove the item. So we go to the inventory input handler, and when we try to throw an item away, we simply remove it from the inventory. So we know that we have active slot index. So this particular index, we want to remove all items from that particular slot in this inventory. So we also will want to spawn the item. I'm not sure if you remember, but I said over here that we'll straight away add this parameter to our remove item method, and we'll implement that in a moment. And there is one more thing we have to do, because we don't check if this slot has item. For that, let's quickly add another small method that will return the inventory slot, and let's call it getActiveSlot. And this will return from the slots the slot at the active slot index. As simple as that. So we grab that method, and inside of our inventory input handler, we check if the active slot has some item, right? If we want to remove something, would be good to have something there. Otherwise, we'll want to do an action. So over here, this should be enough to start removing items from our inventory. So let's collect something and let's press F. This item got deleted, and this one and this one. So this part works as expected. Now we have to push the item to the ground or throw it. For that, we need to modify a little bit our game item prefab, because it doesn't have rigid body. So I'm closing all the components we have already there, and I'm adding rigid body 2D. So now I want to set the gravity to 0, because I don't want the items to start falling by default. We could also freeze the rotation, so basically what will happen, the item won't behave strangely. So this is all. I mean, sometimes you may want to have the rotation enabled, it's up to you, but in this case I will just freeze it. And I think this is all I need over here. So we do that, and now we can override the prefab. So I click on the rigid body 2D, apply to prefab game item. Awesome. So now if we have a look at other prefabs, right, of this type, they all have the rigid body 2D. Awesome. Now, there is a small strange thing that we need to do on our game item. So basically, when the game item is spawned, we have to disable its collider for a brief moment. Basically, when we throw the item collides with us, right? So it is in our item detection trigger. And we wanted first to get out of the item detection trigger to get activated so they don't, so we don't grab it straight away. So for that, on the game item, let's create coroutine. But before we do that, we'll need also to get the collider reference, right? So we can do that. So private collider 2D, and let's call it collider. Then I don't think we have here. No, we don't have the private. We don't have the awake method. So private void awake collider get component collider 2D. Awesome. Now we have collider, so now we can disable it, right? So at the very beginning, we can basically set that it's not enabled. Easy. So now on the start method, so private void start, we want to start a coroutine that will enable this collider after a brief moment. So for that, let's create a start. Let's call start coroutine with our method, which will call enable collider. And it will require some parameter, but we'll do that in a second. So public enumerator. Once again, be careful because there are two types. So one is generic. We don't want the generic one. We want the one without any type. So over here, we call it enable collider, and let's give it the parameter of type float that will basically ask how much time we want to wait before enabling the collider. So after time. And we can make it private. What I will do is first I will wait yield return new wait 4 seconds after time. So this basically will wait for that time. If you are not familiar with enumerators and enumerables, this syntax may sound or look strange, but yes, you need to use the yield return and then basically return the type of coroutine that we want. So we are using this one, which will allow us to wait for this particular amount of seconds. And after the time passes, what we want to do, we want to enable the collider. So we do that. We start our coroutine and we need some time, right? So let's allow the user to set the time themselves. So serialized field, private float collider enabled after. And maybe by default, let's put there 1 second. So collider enabled by default. So just to let you know, there is a much better way to do that. Just don't want this tutorial to really grow and grow in size. Basically, the main idea would be to, instead of disabling the collider, would be to ignore the collision when we spawn the item. So we would have a field on the game item saying that inside the item detector, and it would be set to, for example, true when the item is spawned. Then once the item left the detection zone, basically what would happen, the collisions with the detector wouldn't be ignored anymore. So that's how it would work. This way, basically, the item cannot be thrown through the wall or anything like that, because here we have this problem, right? If we disable collider, the item can just go through walls and stuff like that. But for now, it will do. And basically when we spawn the item, we want it to have a little bit of movement, right? So it flies away. So let's create a method and call it throw. So public void throw. Now we want to know in which direction we should throw it, right? Because our character can be facing 2 different directions. For that, we'll need the reference to the rigid body. So we can grab it here. Rigid body to D. We can grab it over here, so rigid body get component, rigid body 2D. Awesome. We have it. So now we can grab this, and actually let's add one more variable. So serialize field, private float throw Actually, we need several fields. So let's maybe do that. Let's create header here so they are nicely grouped together. And let's call it throw settings. First, once the item is flying, we would like to know what should be the gravity, right? So throw gravity. And let's default it to 2. Then we'll want to randomize a little bit the throw. So we want to randomize it in the x-axis. So let's do min x force. And let's default it to 3 maybe. Then let's create another one for the maximum force. So max x force. And then we also need one for the vertical force, right? So serialize field, private float, and throw y force. And over here, let's put 5. So let's also add the throw over here, just so we know it's about the throw, not about anything else. And I think those are all we need. So we can go back to our throw method. And first thing we want to do, we want to enable the gravity. So we want to set the gravity scale to the throw gravity. So that's the first thing. Then we want to select the random x force. So throw force x will be random range, and now x throw force min x max throw x force, right? Great. So this will be basically return us range between this number and this number. So between 3 and 5 in our case. Awesome. So now we want to set the velocity of the game item to new vector 2 math f dot sign x dir. Basically, depending on the parameter, if we give here 0 or positive, it will give us the right direction. Otherwise, it will give us the left direction. That times the throw force x, and then we want the y force over here. Just to keep it consistent, maybe let's rename it the throw x force. And now it's consistent with the rest of variables. Okay, and now we also need a coroutine to basically stop the flying, right? So we create another one, enumerator, and let's call it disable gravity. And this one will be slightly different because it won't wait for a time, but rather it will wait for a particular velocity. So float at velocity, just to make it even more specific, at y velocity. And now what we'll do first, yield return new wait until. Now we have to provide the arrow function that will return boolean. So basically we want to check if our y velocity is smaller than the at y velocity. So basically what that means, let's say we throw it, at our case we throw it with velocity 5 up, right? So it will start going up, the gravity will make it slow down, at a certain point it will stop, and then it will start falling. So the velocity will be negative. And at a certain point it will reach a -5, right? So it will, and this will be more or less around the same point that we throwed it from. So it will be just nice little jump like whoop. So then what we want to do, we want to stop it completely. So velocity vector to 0. Awesome. And then what we want to set the gravity scale to 0. And now, of course, we cannot forget to start this coroutine. Awesome. So at this moment, just let's have a look. We should start the game and nothing should really change. Okay, so the items do not throw away or do not fly away, so it means everything is set up correctly, at least at this moment. So now we need to spawn the item, right? When we remove something from the inventory, we want to spawn it and then throw that particular item. So for that, we'll need another script, and let's call this script game item spawner. So game item spawner, And the script will be pretty simple. So first of all, we want to have a reference to the prefab of the item base, right? So the game item. So item base prefab. Awesome. Then we want to have a method that will allow us to spawn that item. What's important? Based on the item stack. So we want to know what item to spawn, right? We don't spawn just random things. And first thing we need to ensure is that we have the prefab. Otherwise, we'll receive the exception and we don't want that. So return. Now we start by spawning the prefab. So instantiating it. Prefab utility, instantiate prefab, item base prefab as game object, of course. Awesome. So we have that. And now we want to set its transform position to the position of the spawner itself. You may be wondering why I'm not providing the parameters over here. That's because the instantiate prefab doesn't have the convenient methods that the regular instantiate method has. So we have to do everything step by step, which is all right. Not much work there. Now we want to grab the game item script from the item. So get component and now game item. Then on that particular game item script, we want to set the stack to the copy of the stack that we received over here. So item stack and now item and the number of items. Okay, I see this one is probably has a private setter. So let's have a look. Stack. Yeah, it has it has no setter at all. So let's create a method that will allow us to do that. So public void set stack item stack, and now we basically want to set our stack to the stack we received. Awesome. So now we can use the set stack and just provide it over here. So another important thing is that we have to add is that we need to set the game object, right? So set up the game object also at the beginning of the start method, right? So over here we did it in the inspector. So when we change something, the game object will be set up properly. But once we spawn it, there is no logic for that. So we don't call it on awake, we don't call it on start. So now we do, right? So I added it over here, and this will ensure that the game object is set up properly. We go back to the spawner, and there is one more thing that we can do now. So game item script and our beautiful method called throw. Now we want to use the spawner local scale x as the x direction, right? Because if my character is turned right, that means its local scale is positive, and if it's basically negative, it means the character is looking left. As simple as that. Now we have this method, which is not called anywhere yet. So we go back to our inventory, and our inventory has this spawn place, right? So we want to be able to spawn the item. Let's change this condition a little bit. So if we request spawn and we try to get the component of type game item spawner, because there might be some items that may not be allowed to spawn items, for example, and we store it in variable, so out var, and let's call it item spawner, and on the item spawner we simply call spawn item, and we provide the state from that particular slot. So over here and then state. So this is the item stack, and it will be spawned over here. So that should be it. Let me double check that. So let me test it. So we have our character, nothing broken, and we press F and nothing is happening. Why? Of course, because we forgot to assign our game item spawner. Now we saved it. Now we need to set the reference to the game item prefab. Just to make a final test, let's add some extra items. Let's make the red flower. Maybe let's copy and paste it, that will be quicker. Then another health potion, another red flower, another planks, then maybe some nails over here. Let's change their number and let's have a look if everything works. So we can pick up all the items, and now we shouldn't be able to pick up the red flower, but we should be able to pick up the planks. Yay! And we should be able to throw everything around as we please. Awesome. And really everything seems to be working as expected. So you see, the interesting part is that for this 1 second we don't pick up the items. I hope you enjoyed this tutorial. Until now, it is probably the largest tutorial of all I made. It's really massive. It's over 2 hours long. So I would really appreciate you leaving a comment, your opinion, giving a thumb up and subscribing to my channel. Of course, I'm aware that this inventory system is not complete. There are many things that could be added, that could be improved, and I plan on doing that. And as said before, all the code will be available on my Patreon, and hopefully also with the improvements, which will come pretty soon. So if there is something missing, you would like to see some addition to the system, please let me know. I will be glad to add them, especially if you are my patron, then that will be one of my priorities, of course. And of course, have a fantastic day. Love you and bye bye.